Suppose we have counting problems that involve factorials. The calculator can do these calculations as long as the number of trials is less than 70. The calculator will give an overflow error because the number is too big at this point for the memory. 70 factorial is a very large number, and the calculator's memory cannot store all of the digits accurately. So let's assume we want to find the value of 7 factorial. So we hit 7, we go under Math, highlight PRB, and go down to where the exclamation point is. That is the factorial. We can go ahead and hit Enter, and we see that 7 factorial is 5040. As long as you are considering a non-negative integer or a positive integer multiple of 1/2, the calculator can do this. Our next example is 0 factorial. So we go type 0 in, hit Math, scroll over to PRB, and select the factorial option. And we get 1. 1/2 factorial, exact same key sequence, and when we do that, we end up with that value. But if I try to do -1 factorial, putting the -1 in parentheses, I get a problem. And this is correct. -1 factorial doesn't necessarily exist. So let's try another example. So let's say we try to do 3/4 factorial. So we hit Math, scroll over to PRB, and select option 4. And when we try to do this, again we get a domain error. Now, when we tried another fraction that's not an integer multiple of 1/2, we get this error message. As we understand 0.75 factorial, it does exist, but the calculator has a program that is not equipped to compute it. We need what's called the gamma function. And integer multiples of 1/2, when used in the factorial, happen to be multiples of the square root of pi. And this can be evaluated using the specific program that the calculator uses. So this is how factorials can be done on the TI calculator.